Good morning, everyone. Thank you so much, Allison, for the introduction, and thank you to Duke for having me here today. Really excited to kick off this day of talks by speaking a little bit about the potential for living shorelines to enhance coastal sustainability and resilience here in North Carolina. So I'll start by just briefly mentioning the fact that coastal habitats like the salt marsh behind me and oyster reefs and seagrass beds all provide really valuable services to humans, ranging from coastal protective services to carbon sequestration to providing habitat for the fish and crustaceans that we like to eat. But these habitats are also globally threatened and degraded for a variety of human and natural induced reasons. And the one I'm going to be talking a couple of slides about is something called shoreline hardening. And shoreline hardening is the placement of some kind of hard, fixed structure right at the land-water interface for the purposes of reducing erosion or protecting upland infrastructure and lives. And shoreline hardening has been increasing at an unprecedented rate all over the globe. Over 14% of the US sheltered coastline is already hardened, which is pretty crazy when you think about the fact that 1 mile out of every 7 miles of coastline in this country has some kind of artificial structure on it. And so shoreline hardening comes in many different shapes and forms, ranging from seawalls on the left side, which are typically very large and found along oceanfront shorelines. We actually have pretty good policies in the United States that protect against this kind of future development. And so I'm going to be focusing mostly on inland estuarine protected shorelines, where we see a lot of riprap revetments, which are these kind of sloping rock structures made out of granite boulders or old bits of road concrete. And then the most common structure that we have here in North Carolina and all over the US are called bulkheads. They're essentially scaled down versions of seawalls for estuarine shorelines made out of this corrugated sheet pile. And shoreline hardening can be problematic for a couple of reasons. First of all, it quite literally cuts off that connection between the land and sea. So for organisms that like to kind of migrate freely between those two zones, this can create a physical barrier to their movement. Also, these structures have been shown to ultimately lead to habitat loss seaward of them, and this is particularly concerning in the context of climate change and sea level rise. Because if you have an unimpeded salt marsh with a rising sea, it might be able to slowly migrate upslope as sea level rises, but if you have a wall there that prevents that migration, then that habitat can be squeezed out and drowned, and then we lose all of the services that humans get from those habitats. Along those lines, some of our work has shown that hardened shorelines have reduced biodiversity across all sorts of animal and plant groups. On a more social side, these shorelines can actually trigger erosion of adjacent properties. So you can imagine if you start with an expansive natural salt marsh and one homeowner comes in and they build a wall, now their neighbors might have to build reactionary walls, and we see this sort of cascade in shoreline hardening and habitat degradation. And then finally, there's the potential for these walls to actually encourage development in risky areas by making them appear safer. So you might be wondering if shoreline hardening has so many ecological and social consequences, why do we keep hardening shorelines? And this was something we are interested in investigating here in North Carolina. And so we did a survey back in 2014 of about 600 waterfront property owners. And so each little red dot in that map is one of our respondents to this survey. And we wanted to know, first of all, what do homeowners prioritize when choosing how to stabilize their shoreline? So this first figure is just showing how homeowners ranked their priorities. We found that homeowners prioritize effectiveness, cost, and durability. Ecological impact is a pretty distant fourth. And then we also followed that up by asking homeowners to rank common shoreline stabilization strategies from bulkheads to riprap revetments, breakwaters, and restored marsh plantings based on how they perceived their effectiveness. And we found that homeowners think that bulkheads are their most effective option. And so going forward, if we want to promote nature-based infrastructure alternatives, we need to probably be talking about how effective and cost-effective they can be in the long term, rather than just talking all about their ecological benefits. So what are our alternatives? And that's where living shorelines come in. So according to NOAA's definition, a living shoreline incorporates vegetation or other soft elements alone or in combination with some type of harder shoreline structure, like an oyster reef or a rock sill breakwater for added stability. So it's really important to mention here that living shorelines are kind of an umbrella concept that cover a whole bunch of different shoreline designs, ranging from pure habitat restoration, so just restored marsh plantings on the greenest end of the spectrum, up to habitat restoration in combination with built infrastructure, like a granite sill or a granite breakwater. And so this picture behind me is a very common type of living shoreline that we have here in North Carolina called a marsh sill. And so it combines restored marsh plantings, typically Spartina alterniflora, with this fringing sill made out of granite rocks. You can see there's been some oyster recruitment onto the rocks. So now potentially you get the added benefit of restored oysters. And there are mandatory gaps in these sills so that crabs and fish can still access the marsh behind these structures at high tide. Living shorelines, depending on where you are in the world, can incorporate all different types of habitats. So sometimes they have coral reefs or mussel beds or seagrasses or kelps or mangroves. But I'm going to be focusing on these sort of oyster or salt marsh hybrids. And so living shorelines have the potential to outperform hardened shorelines for a couple of reasons. First of all, they keep that connection with the land so that organisms can now still move sort of freely between that terrestrial and that marine environment. And they also don't prevent the upslope migration of those habitats with sea level rise anymore. You also maintain all of the services that humans get from whichever habitats are incorporated into these designs. Now, because you've added this structural component to these shorelines, they have enhanced wave attenuation over what just a natural salt marsh might have. So they're offering a little bit more of that service to humans, potentially. Work in North Carolina has shown that actually there were more juvenile fish at these hybrid living shoreline than even along natural reference marshes, and way more fish than along hardened shorelines. And then finally, and maybe most interestingly, these shorelines have the potential to keep pace with sea level rise. Because they incorporate living habitats that can grow and change as conditions change, this might mean that we don't have to go in and spend a lot of money continually updating them. And also in the context of storms, if parts of these shorelines get damaged, there's the potential that the marsh can just regrow in those areas, or the oyster reef can regenerate. But we know from our survey work that homeowners don't really care about all these wonderful ecological benefits. And so we need to know more about how effective these structures can be. And so with that in mind, we set up a pretty big field experiment back in 2015 with sites ranging from Ocracoke in the north down to Southport in the south. And in each of these regions, we had replicated natural marsh shorelines, living shorelines that had this granite sill and planted marsh grasses and bulkheads. And we looked at how the elevation and vegetation profiles of these shorelines changed over 2 years, including right before and right after Hurricane Matthew in 2016. And so I'm just going to show you one quick figure from this. This is comparing shoreline on the x-axis, so natural marshes in green, living shorelines in gray, bulkheads in black. And it's looking at the change in landward elevation from before to after the storm. So if the dot is above the dashed black line, that would mean that these sites were gaining elevation. If it's below it, it means that they're losing landward elevation. And so the big takeaway from this figure is that all the living shorelines in our study roughly maintained elevation from before to after the storm, which is what you would want. Whereas both bulkheads and natural marshes lost elevation. So living shorelines are significantly resisting erosion better than both of these shorelines, at least in this one particular storm. And then also really interestingly, 75% of the bulkheads in our study had some kind of visual erosion or structural damage. So this was one of our bulkhead sites. You can see that a bunch of the boards on the top were popped up. There was a lot of landward erosion. Homeowners had to come in, They had to bring a contractor in to replace those boards, bring in sediment, resod the grass. And then interestingly, same site post-Hurricane Florence this last fall, same exact thing again. A lot of damage to the structure, tons of landward erosion, and we're seeing these repeated patterns of damage. And so again, 75% of the bulkheads in our study had visual erosion or structural damage. 75% of natural marshes had some kind of visual evidence of landward erosion of that edge, whereas there was no obvious damage to any of our living shorelines or any obvious damage of migration of that marsh edge. And then just to show you one more set of pictures, because this one is pretty instructive. These photographs were taken in 2011. On the top, you have a brand new living shoreline with that rock sill. You can even see some of the new marsh plantings. And on the bottom, you have an aging bulkhead made out of concrete. So these photos were taken right before Hurricane Irene. And then right after Hurricane Irene, no obvious differences to the living shoreline other than an elevated water level, whereas the bulkhead on the bottom had been completely ripped out. Took the homeowners 2 truckloads of sand to replace that, and it cost them about $20,000 out of pocket to replace that shoreline. And one very important thing that I didn't mention is that these 2 shorelines are separated by less than 100 feet of natural marsh. So they're almost perfectly adjacent to each other. And so to kind of summarize these thoughts, traditional shoreline stabilization structures are generally going to be bad for coastal habitats, but they also have high rates of damage and they're going to be very expensive to maintain, particularly in the context of climate change. And living shorelines have the potential to be just as effective as hardened shorelines with a fraction of the maintenance costs, and they actually incorporate habitat restoration into their construction. And that's all I have.